Alright, hi. Uh, this is Mew Following, and today is the fifth day since I decided to learn the data structure and algorithm by OpenDSA. Now let's begin today's reading. Okay. Okay. Maybe I should start from the beginning. Will be better. Data structures and algorithms. No, maybe because we don't have much time today. So when I got more time, and I will start it from beginning. But today we just jump out the new progress. Shall we? Alright, I think here. Resource constraints. Philosophy. Okay. I think yesterday we got here. We are here, right? Yeah. Asymptotic analysis. Asymptotic.
Asymptotic analysis.
Asymptotic analysis. Alright. I still don't know the words meaning. 1112. A philosophy of data structures. You might think that with ever more powerful computers, program efficiency is becoming less important. After all, processor speed and memory size still continue to improve. Won't today's efficiency problem be solved by tomorrow's hardware? Alright. Alright. The beginning of this section, she had no, she not she. The writer is have a hypothetic
Hypothesis.
hypothesis that us reader will think when, because the last part, the last section is saying how to tell a solution is good or bad. And the way we got two way, right? One way is for in the humans aspect, and in a human aspect, we want the solution will be good to understand, and good to code, good to maintaining, and good to debugging, good for debugging. And the second standard is for computer. For computer is saving the more resources, and it's a more good way. And so in a section we just read today, and he say writer has a hypothesis that we will think, oh, if computer is becoming better, the hardware is becoming better, and efficiency will be better, so we don't need to consider about computer. They will be they will be good if just if just put this problem after today. Yeah, just wait until the hardware upgrade. But I think no. And let's continue. As we develop more powerful computers, our history so far has always been to use that additional computing power to tackle more complex problems, be it in the front of more sophisticated more sophisticated user, be it in the form of more sophisticated user interfaces, bigger problem sizes, or new problems previously deemed computationally infeasible. More complex problems demand more computation, making the need for efficient programs even greater. Unfortunately, as texts become more complex, they become less like our everyday experience. So today's computer scientists must be trained to have a thorough understanding of the principles behind efficient program design, because their ordinary life experiences often do not apply when designing computer programs. Alright, let me read. As we more powerful computer, our history so far has always been to use additional computing power to tackle more complex problems, be it in the front of more sophisticated user interface, bigger problem size, or new problem previously deemed
computationally
infeasible. More complex problem demand more computation, making the need for efficient programs even greater. Unfortunately, as texts become more complex, they become less like our everyday experience. So today's computer scientists must be trained to have thorough understanding of the principles behind efficient program design, because their ordinary life experience often do not apply when designing computer programs. This session, I think, is basically saying when I want to say 道高一尺，魔高一丈, but I'm using English. So, when you prevent more powerful computer hardware or something, the problem you want to solve is more complicated. I think it's saying this meaning. In the most general sense, a data structure is any data representation and its associated operations. Even an integer or floating point number stored on the computer can be viewed as a simple data structure. More commonly, people use the term data structure to mean an organization or structuring for a collection of data items. A sorted list of integers stored in an array is an example of such a structuring. These ideas are explored further in a discussion of abstract data types. Okay. Data structure is any data representation and associated operation. Data representation and associated operation. Even an integer or floating point number stored on a computer can be viewed as a simple data structure. More commonly, people use the term data structure to mean an organization or a structure for a collection of data items. A sorted list of integers stored in an array is an example of structure. These ideas are I think this section is saying in a wide way, data structure can be anything of the in the computer science about data. Yeah, even because it's saying even an integer or floating point number can be viewed as a simple data structure. It's a simple data structure. And a bigger data structure, you can mean the organization or structuring for a collection of a data. I think it's like even it's the number integer or a floating point. It can be you can say it's a data structure. And even bigger, like a whole data set, like a table, like SQL table, you can say it's data structure. I think it's saying this meaning. Okay, given sufficient space to store a collection of data items, it is always possible to search for specified items within the collection, print or otherwise process the data items in any desired order, or modify the value of any particular data item. The most obvious example is an unsorted array containing all of the data items. It is possible to perform all necessary operations on an unsorted array. However, using the proper data structure can make the difference between a program running in a few seconds and one requiring many days. For example, searching for a given record in a hash table is much faster than searching for it in an unsorted array. Alright. Print. most obvious maximum percent sorted array possible to perform all necessary. However, using the data structure can make a difference in a few seconds that will require many days. For example, searching for a given record in the hash table is much faster than searching for it in an unsorted array. Okay. This section is interesting. It basically saying, it basically comparing with, if you solve a problem, use data structure concept, and with no data structure concept, it may be cause the way different result, and the difference will like many days, or just in a one concept, it will be how to say 差异. The difference will be the huge gap. Yeah. Okay. A solution is said to be efficient if it solves the problem within the required resource constraints. Examples of resource constraints include the total space available to store the data, possibly divided into separate memory and disk space constraints, and the time allowed to perform each subtask. A solution is sometimes said to be efficient if it requires fewer resources than known alternatives, regardless of whether it meets any particular requirements. The cost of a solution is the amount of resources that the solution consumes. Consumes. Most often, cost is measured in terms of one key resource, such as time, with the implied assumption that the solution meets the other resource constraints. Alright. Efficient if it solves the problem with the required resource constraint. What is resource constraint? Example of resource constraint include the total space available to store the data, possibly divided into separate memory and disk space constraints, and the time allowed to perform each subset. A solution is sometimes said to be efficient if it requires fewer resources than no alternative, regardless of whether it meets any particular requirement. The cost of solution is the amount of resources that the solution consumes, most often, and the time allowed to perform it. There's one key source such as time, with the implied assumption the solution meets the other resource constraints. Solution is if it solves problem. Um. I think it's reinforcing the concept.强调 it is emphasizing the concept that the writer is always in this section is emphasizing the whole concept is so a solution is efficient, is elegant. It must, if a solution is efficient, then it must be solved the problem within the required resource constraints. Yeah. And yeah, and it made an example for this. Yeah. So you have to save the time, save the space, and be a good solution if you're learning data structure and algorithm. I think it is the philosophy of data structures. Alright, and it's time to sleep. Today we got not so much time, but I learned a part anyway. Yeah. This is today's progress, and we will see you tomorrow. Bye bye.